All right, you guys, so our second video on horizontal asymptotes, and that is we're going to go over the slant asymptote. Well, we say it two ways. You can say the slant asymptote, or we call it the oblique. I hope I spell oblique correctly. Oblique asymptote. And that is when the degree of the numerator, so here we have the degree of the numerator is to the third power, is greater than the degree of the denominator, and this one on the denominator is just to the first power. And that's going to be a slant or oblique. It's going to actually, the asymptote is going to be a function. And we're going to divide in order to figure that out. So hopefully you were able to watch the video for dividing polynomials, or you were in class when I went over the video when I actually did it in person, the dividing polynomials. But I should be in class also if you need help with this. So let's take a look. Let's see, I graphed it here. This is the actual rational function. It's pretty funky. So you can see why we're going to need some help finding that horizontal asymptote, right? So let's go back here and let's do the actual long division. So let's see, our dividend is x cubed minus 3x squared plus 2x plus 4. And our divisor, or the amount that we are dividing it into, is, I just can't make those lines straight with this pen, you guys. X minus 2. Okay, so we just need to look at here. What can I multiply x by to give me x cubed? And that's just going to be straight up x squared. Now I'm going to multiply it by the divisor out here. X squared times x is x cubed. And then minus 2x squared, don't forget, I had to distribute this x squared. Here I multiplied here. And then I also multiplied here, okay? And now I'm going to actually subtract. I have to subtract all of this. So I'm subtracting x cubed, that cancels. Then I'm subtracting negative 2x squared, which makes it become positive. So this negative 3x squared plus 2x squared just becomes negative x squared. Bring down my next component. Okay, so x can go to negative x squared. We're going to subtract just an x. Okay, and distribute that. I get negative x squared. That's what I wanted. I wanted exactly the same thing so that when I subtract, it cancels out. And then negative x times negative 2 is plus 2x. So actually, all of this cancels out. I'm left with 0, right? But I'm going to bring down my positive 4. But x cannot go into just 4. So actually, this ends up being my remainder, right? So it's going to be x squared minus x, and then plus 4 over, my remainder, 4 over x minus 2. So that's the actual quotient, is x squared minus x plus 4x minus 2. All of that is the answer I get from my long division. However, I didn't need to write down the actual remainder because the asymptote, the oblique asymptote, is just right here, this x squared minus x. Okay, so that's the answer, that's the asymptote. Let's go ahead, x squared minus x, put this back into that graphing calculator and see what it actually looks like, right? X squared minus x. So let's come over here, x, and this is a pretty cool app website, you guys. Desmos, I'm sure some of you have used it. Okay, x squared, oh, I put minus 2, minus x. Okay, so our original is the orange, and our horizontal asymptote, our slant asymptote, is the red. And then I'm going to come over here and I'm actually going to zoom in so you can see. Okay, so it originally looked like they kind of overlapped, but as we zoom in, you can tell the function does not exist right? Wherever this slant asymptote is, okay? And I can get closer and you can just tell it doesn't exist there on both sides. So I can check myself with the calculator and realize it's correct. And isn't that crazy what it looks like? And the asymptote, remember, it doesn't exist there, but it's going to get closer and closer and closer. It'll just never touch that asymptote, okay? So let's see what it looks like when we zoom out. It almost looks like, let's see if you can follow the hand over here. Almost looks like it overlaps, but we know when we zoom in there that it's just getting super close. Oops, so that didn't follow it, you guys. It's just getting super close, but it doesn't actually hit that, right? And that's the whole thing about an asymptote, is it gets close, 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 but will never actually be at that point. The function doesn't exist there. So we're going to have some practice problems on there. Look back at the page that has all that information there and call me over if you need help with any of those practice problems.